Hi everyone, welcome back. Let's see one of the gate question which was asked in the earlier years on the concept of Banker's algorithm. Let's read the question. Guys, the question looks somewhat larger, but once you know the concept of Banker's algorithm, it is easy for you. Okay, without wasting any delay, let's read the question. An operating system uses Banker's algorithm for deadlock avoidance when managing the allocation of three resource types X, Y and Z to three processes P0, P1 and P2. Means they are using Banker's algorithm to make the avoidance of deadlock, and three resources they are using, one is X, Y and Z for the three processes P0, P1 and P2. That is what they have given. Let's continue the question. The table given below represents the current state of the processes. Means this is the table that they have given already. Here the allocation matrix shows the current number of resources of each type allocated to each process. Means if you look into the table allocation, what are the things that they have given? That numbers defines the current number of resources allocated for each and every process. And max matrix shows the max number of resources of each type required by each process during its execution. Okay, fine. Which means this particular matrix is defined that for P0, how many number of maximum resources required? 8, 4, 3 are the maximum resources required. Out of that, how many are already allocated? 0, 0, 1 are already allocated. That is the meaning of that above first para. Let's read the continuation. There are 3 units of type X and 2 units of type Y and 2 units of type Z are still available. Means available resources in the operating system are 3, 2, 2 after allocating. That is what, right? Still available means after allocating, these are the available resources. The system is in currently safe state. Right? Generally, we are using the deadlock avoidance concept is meant for to define whether the given system is in safe state or not. Right? Once system is safe state, then only we can go for allocation. Right? Now they are saying that it is in safe state. Consider the following independent requests for additional resources in the current state. Means here they have given two requests, request 1, request 2, like P0 request for 0, 0, 2. That is what they are giving. And P1 request for 2 units of X, 0 units of Y and 0 units of Z. This is what they have given. Which are the following is true? Only request 1 is permitted, only request 2 can be permitted. Both request 1 and request 2 permitted, neither request 1 nor request 2 permitted. Means whether deadlock is happening or not with respect to these P0 and P1 request, that is what they are asking, right? So guys, once you know the Banker's algorithm, this is easy for us. So initially the request one will try to check whether it is avoiding the deadlock or not. Request one, what is happening? P0 process requesting for allocate 002 units of resources, right? When it requests for 002 units of resources, what will happen? We are going to subtract it from the availability of the process, because this satisfies the availability condition. So I can say that 3, 2, 0 is the availability now, right? Then this 002 will be allocated to which process? Process P0. See guys, I am using the green color to represent the first one, request, right? Now what are the resources available now? Allocated 003 are allocated, because 002 is the one which we got requested now, right? Once we got 003, if we want to move further solving of the example, I have to define the need. What is the need so far? That's what you have to define, right? What is the need of P0? P0 need is 8 minus 0 is 8, 4 minus 0 is 4, 3 minus 1 is 2. Guys, just go with the earlier videos of the Banker's algorithm so that you can able to understand how to solve this one, right? So otherwise just go ahead with the understanding this one only, you can able to clearly know it, right? So need of x means what? Maximum allocated, maximum resources required to complete the process minus so far allocated, that is what 8 minus 0 is 8, 4 minus 0 is 4, 3 minus 3 is 0 guys, this is 0, 3 minus 3, now after allocation it is 0, right? Yes. What about the remaining things? 6 minus 3 is 3 and 2 minus 2 is 0, 0 minus 0 is 0. And what about this one? 3 minus 2 is 1, 3 minus 1 is 2, 3 minus 1 is 2. This is what? The need, right? So now try to check. Now availability so far is 320. Can it satisfy anything? Yes. 300 is less than or equal to 320. Anyhow, first one is not satisfied. So second one, 300 is less than or equal to 320. Yes. When it is satisfied, what we will do generally? We will make it allocate. We will make it subtract from here 300. So now availability is 020. Guys, if you are thoroughly working with the practice mode, you can able to directly write it. But I am trying to do it with respect to algorithm. So now 300 is added here. If 300 is added, this will be equal to 620. Equal to 0. Now this one is leading to 00. Good, right? So definitely after a certain point of time, P1 completes its task. Now what will happen? 020 plus 620, that will be 640. So now availability is 640. Right? 640. Now with respect to 640, just think which can satisfy any other request. Try to check. Is 840 less than or equal to 640? Condition failed. It couldn't possible. Is 122 less than or equal to 640? So first two are satisfied, but what about third process, third request? It couldn't satisfy. So third also. So P0 is not satisfied and P2 not satisfied. So this particular request one is led to unsafe state. Is it okay, guys? Yes. So request one is not permitted. So based on that, we can say that request one is permitted, it is saying. So option A is false, definitely. Based on that, option C also false, because request one permitted, right? So option C is failed. Now let us go with the process P2, process P1, sorry, request 2. So what it is happening? P1 is requesting for 200. So far, what is the availability for us? Availability is XYZ, which is 322, right? Now it is requesting for 200. So the leftover one will be 122. Leftover one will be 122. When it is allocated with 200, what will happen to this 320? That will be updated with the 520. Am I right? So as I am having space constraint, I am trying to write here. While writing the notes, you have to go with clearly, right? That 200 allocated to here. So now the allocation is 520. Allocation is 520, and P0 is 001, P2 is 211. Based on this, can you write the need of the process so far? For P0, the need will be 842. 8 minus 0 is 8. 4 minus 0 is 4. 3 minus 1 is 2. And for the P1, 6 minus 5 is 1. And 2 minus 2 is 0. 0 minus 0 is 0. And for the P2, 3 minus 2 is 1. 3 minus 1 is 2. 3 minus 1 is 2. This is the need, guys. Need of P0, P1 and P2 and P2. Now check. What will happen? Does 122 is greater than any of the process? Yes. Which one can be satisfied? I will go with the black color. Which one will be satisfied? Can be P1 will be satisfied? Yes. Definitely P1 will be satisfied. Right? When P1 is satisfied, let's try to check why we need to apply the algorithm every time. See, algorithm is a certain procedure, but when we going with the like comparative point, whether we are following algorithm or not, they won't check. They will check only the answer, right? So the need is 100. Why we need to subtract the 100 and you are going to get availability, and that I need to add back, and I have to get the maximal, all those things. Instead, what we can do, instead of subtracting it and doing like that, finally you are going to get released by 520 maximum process. Am I right or not? Yes. Finally, you are going to get this 620. Right? Generally 620 you are going to get. But the thing is, as you are not subtracting 100 from the availability, I will directly add the actual allocated. So which will be 642, guys. So you might get confused certain here. Just think once, right? Instead of subtracting 100 from here, try to observe what I am trying to do. 122, I am trying to subtract it from here, so that you are going to get 022. Then that 100 is going to be added to which one? Allocate only. 100 if it is added 620, that 620 you are going to add again here, which is equal to both are same or not. That's what I am saying, right? Instead of doing subtraction all those things, means instead of following the algorithm, just go ahead with writing the all allocation value 642. Now the 642 will be satisfied by any process. P0 doesn't satisfy. What about the P2? Yes, P2 is satisfied. So once the P2 is allocated, it will release 211 resources. So which means 853, right? If it releases 853, having 853, does the P0 is satisfied? Yes. 842 less than or equal to 853, so it is satisfied, right? And they are not asking for any calculation whether it is permanent or not. Yes, it will lead to safe state. Based on that, I can say that option B is the correct answer, and option D I can able to eliminate it, right? Yes, right. So the correct answer is option B. Hope you understood this example clearly.